Hello, everyone. How are you doing?
Good.
Everyone good? Hey, that's really nice. I'm a bit nervous, but I'll try to make it correctly. Thank you very much. Just change it a bit. Okay. Okay, can you see it? I think you can. So, I will start talking a bit about how you can implement one of the many ways you can implement distributed frontends. This will be a technical example with Tailor, which is a library that was developed by Zalando a few years ago. They still use it a bit in production, but they are kind of getting away of it. But I'll show you like how it feels. My name is Armando. I'm a software engineer at Travix since 2018. I'm originally from Brazil, a really nice beach in Vila Velha, a few hours from Rio de Janeiro. You can follow me here on Twitter or GitHub if you feel like it. Sometimes I speak about some bullshit, but it's kind of cool. Okay, so what we talk about? I'll talk a bit about Tailor. We'll talk a bit about Kubernetes, not that much, but I'll run this example actually using Minikube inside Kubernetes. I'll use Scaffold. How many people here have heard about Scaffold? None. Okay, it's a Google tooling for you to actually develop stuff for Kubernetes. You can actually keep track of your file system and rebuild your container, your image, push it to the registry, deploy it in Kubernetes lively. You don't need to do anything. You just keep a manifest. It keeps track of your files and enable you to make like hot reloading inside your cluster or Minikube, you choose it. So it's pretty cool. It fasts a bit here. And maybe also a bit about Webpack and React, because we will kind of tweak a bit of Webpack configurations in this kind of sense. A small brief explanation about Tailor and what it is. Tailor is built by Zalando. It's a layout service that basically fetches and parses HTML templates in order to deliver like an assembled page to the user. These HTML templates can refer to fragments, which represent small pieces of your UI, and you can just place them around like your template. Tailor also forward request properties from the first request. So the fragments can behave accordingly as needed. One small thing before we start on this is that keep open-minded. This is kind of weird. Not everyone is doing this. Maybe it will not work for you, but yeah, you can learn something about it. So what we want to achieve, basically doing this kind of stuff, we want to have some autonomy in the fragments we're developing and how they actually are implemented. The teams will actually keep them. Also freedom, so they can choose the right tooling for this kind of stuff and build them differently. Scalability as well. So if you have server-side rendering, you don't want to throw your whole DOM hierarchy into the server, and you can just render piece by piece and just get them all tied together after it. Independent builds and also independent deployments. So if you make a change into a fragment, you don't want to redeploy the whole front end, just that small fragment, and get that into place, for example. Am I going too fast? Should I go a bit more slowly? Yeah. Okay, good. So how it's gonna look like? It is a small brief. Let's say you have an empty cluster. We will start with a simple Kubernetes load balancer in the front of it, so you don't have to have different endpoints for each kind of fragment and this kind of stuff. We'll put the Tailor in the middle of it as a layout service, and then it can have different fragments, like X, Y, or Z. Let's say you decouple your application the way you actually want it to be. One nice thing about it is actually you can scale each one of them as you actually need. So if you want to have more Y fragments and X fragments, but you don't need so much about the Z, you can just spend more instances of it, and Kubernetes can actually auto-scale those. So you can handle more requests as people actually want pieces of your page. This is an example about how you can actually implement this Kubernetes ingress load balancer. This is a really simple one, a simple manifest, nothing that much. So basically what we're doing here is we determine the kind is an ingress load balancer. We have some rules for different backends. This is the layout service itself. It will be in the root path always. So you're always hitting the actual layout service. And you have the backends, the fragment itself, to a specific namespace. So you can actually use the same route instead of using lots of different routes. And you can deploy this basically just by running this in your Kubernetes, your cluster itself. We use Tailor as a layout service. You can actually use a different kind of technology for this. You can implement yourself. Anyway, there's also another work on Compokesure, which is kind of cool. Maybe you can kind of do the same. But this is an example of a simplest Tailor server. It's a Node.js application. So basically, you can pass like a template path to it and just give it to a native Node.js HTTP library. Nothing that much. It's really straightforward. You can give it some different configurations as well. For example, how does it can fetch the templates? How does it can actually request for the fragments and etc. You can intercept those and change like the configurations of it. And this is an example of a template, for example. So it actually has like this fragment tag because they implement it. They will parse it, and you can basically put a URL of your fragment here. We'll get to the point of what is a fragment in the next slide. So a fragment is actually Tailor considers any server that actually returns markup a fragment. If it returns a link header specifying like some assets, it will also include it in the final page. So if you have any kind of JavaScript that is dependent, that template actually depends on, or any kind of style, you can just make your server return that in a header, and they will actually get injected to the page. Easy as that, not that much. This is the most simple type of fragment that we have. It's a simple server that returns a div. Nothing that much. It will inject, like if Tailor requests for it, it will just inject this div into the template and get you right away with that in your markup. You have like a fragment serving assets. So as I told you, if you just put like this link header pointing to all your kind of assets, it will also be injected by Tailor on them. One interesting thing about Tailor is actually it uses asynchronous modules definition. Anyone here knows about require.js? Yeah, require.js. It worked with like I think Essentia uses this kind of stuff as well. So it uses it under the hood. It will inject you like a require.js like a loader inside of the page. So if your JavaScript bundles, they are basically AMD modules. They will be asynchronous loaded as you need, as your page actually needs. So we'll give you like a little run through a little implementation I did about it, and also run it on a Minikube right now. Demo gods, please help me. This is always the hardest part. Okay. So yeah, my computer is not helping me at all. Okay, thanks. Projects, personal finance. So this is a really, I was wanting to prepare another application for this, but this is an application I started experimenting a long time ago. It is basically a list of coffee shops in Amsterdam. Nothing that much. So it will actually like, this is the scaffold I told you about. They have like 3 projects here. We have a load balancer. We have like an API to fetch these coffee shops from a agent, and a front end, which is basically like a learner repository with lots of fragments inside of it. They could also be like different repositories. It's just okay. But each of these repositories actually is a Docker image. Each of these one is a service with their own address, with their own deployment, with their own manifest, their own like CI configurations. And if I change one of those, my CI will only deploy the one that I changed, even though it's in the same repository. It would not like rebuild everything. The scaffold is just like this. Can you read it? I don't believe so. Yeah. Let me just change the theme so I can put something lighter. Okay, cool. So this is a scaffold like template. So yeah, basically what this is doing is basically I have the image names and the artifacts and the context. Where's the source code of these images, and where the kubectl can actually find the manifest of those. So I have 2 commands I can run with scaffold. I can run scaffold dev. So it will start like a development environment. We'll listen to all this context, and if I make any changes, it will actually redeploy that image right away into my Kubernetes cluster. And I can also run scaffold run. So it will just deploy it in any cluster and then leave it away from it. So we'll mainly run here scaffold dev. It will be a bit like a lot. So yeah, I think my minikube is stopped, most probably. Let me check. Ah. Yeah, it was stopped. Sorry, just started. Give me a few minutes. How was the day? How are you finding the evening? You like it? Yeah.
How was the pizza?
How was the pizza? Which one you like the most?
Pineapple.
It will take 1 minute or two. So yeah, let's talk a bit. Let's chit chat a bit. I think I should have left this open before. In my life. Pretty good. Come on, my man. See?
You want to have a question about the fragment? So
Go for it.
It needs to be server-side.
It doesn't. It doesn't have to. If you just make a fragment who returns like the assets, for example, you will just get the assets like injected into the page. But yeah, so basically, if you put like a fragment as each in any kind of URL, like Taylor will try to fetch that URL and just inject it with anything that it returns to. So if it has like a script tag on it, if it has like a style tag, it will be injected in the HTML, and the browser will actually try to load that as well, which sometimes doesn't work that well.
You don't have to build everything before, right?
Yeah, you need to build like to make a bundle of it first, and then you run a server to serve that bundle, so Taylor can actually fetch those. Yeah. And you're talking so much. Why are you doing this to me?
Maybe you can. People have more questions.
Yeah. Anyone has any questions so far?
Doing something.
Yeah, it's getting the VM IP address, it's moving the files into the cluster. It will still take like 1 minute or two. Yeah. I'll send a message to this Google guys. Okay, the machine exists, we're starting cluster components. And then who here already played the build of Minikube? Okay, cool.
You need to make a silly dance to entertain us.
Huh?
You need to make a silly dance to entertain us.
A silly dance? I am the silly dance. Look at my face. I'm getting talent. Oh my god. Okay, I think it'll just 1 minute. Refine API server healthy. Okay. See, that's why I'm asking for a better machine at Travix. Okay, yeah, everything looks great. Enjoy Minikube. Sorry for the waiting. So now if you just run like scaffold dev, it will actually get my Minikube instance. It's building all the images, pushing it to my Docker Daemon inside of it. And yeah, it finished it now. It's deploying other services.
There's still time for the dance.
Yeah, you got it. Thank you very much. So you see, like now it's watching for changes every 1 second. But we basically have like the whole application running well. So it's actually starting now. Like it's building some stuff. This is a really like experimental stuff. So what I did basically is that like when I start the container and I build the server, I build the client code and I serve them, like in the container execution, not in the image build, where it should be, to be honest. So just wait a bit for them to start as well. Some of them already started. Like the login fragment already started, the command fragment already started, the header fragment is building, the layout service is already running. Yeah, they're still building some of them. Now the servers, because you have some server-side rendering in this application. So yeah. For that specific fragment, yes. Like your application will never be fully server-side rendered, just like pieces of it, and then the layout service will actually aggregate all of them and reply that to you back in a really simple way. So this makes actually even like your server-side rendering a bit faster than it actually can be when you act like a single application with a really complex like don't know tree. So yeah, sometimes it helps a lot. Let me just check how it is going in the browser right now. Maybe you can already see something. Let me get the IP of it.
Is that the rendered fragments on the browser side are totally functionally independent? So they are like micro apps already rendered with their own state.
We can even access like the address of the fragment itself, and you only get that piece of render in the browser. Then yeah, okay, we have at 150. 25. Let me try. 1, 2, 15. See how it goes. Okay. SSL. Yeah, it's running. Yeah. If you see, it got actually the server-side render, but the middle list is still not done. Yeah, it's starting like the middle one. It just started them. So now they actually fetch with this. The reason it was not rendering is because like this was a different fragment. So it was out, but those one was already ready to actually serve me them. So it already got them bundled. So this is basically a fully functional application. It have like even like routing, login, this kind of stuff. There's also an authentication like a fragment. It also have like an interaction like with the client. Normally, this is a React application. If I just hit enter here, like it will send a request with the filter query as well, and it will render properly. If I disable JavaScript, it will keep working as well, and the server will not have any kind of exaggerated load. For example, I have like the login fragment. It will not get into this server-side rendering because it's not even in this template. I can change templates on the fly without actually redeploying anything. This is also cool. Cool.
Imagine that I have like a header.
Mhm.
And have these some results that you can grab.
Yeah, it's exactly this case.
How do you communicate?
Custom events. You can use the window custom events to just trigger an event from a fragment, and another one can just listen to them. It actually will give you a little bit of challenges because you need to keep consistency in the event names. So it also demands you a bit of loosely coupling as a developer. But yeah, this is one of simple applications.
Is each of those apps in a Shadowdom container or isolated somehow?
They are each of these apps they have their own containers. If I run, let's go here. If I run kubectl get pods, you most probably see there's each pod for each fragment and for the layout service, for the API itself, and also have like a service for load balancing, which just hides all this interest between itself.
Yeah, well, I mean, is in the page, for example, if you do body background color is wrap in some of the components, will it turn the background color of all those components wrap, or only the one which is in the container?
Well, it depends. For example, if you look at the layout service itself, there is a folder of templates. This is the index template. And I'm injecting like some common dependencies. So for example, all of them use React, so I can make like a common fragment that actually exports React, and they can just load them like using require.js, so I don't have to like have like 7, 8, 10 times like the same React bundle inside the same page. And there's also some common styles, so I can inject, for example, in the main to keep like some fonts, letters, this kind of stuff. It also makes it a bit harder for you like to keep like consistency as in the user interface, because you have a lot of different pieces with different styles in different ways. So this is actually a really challenging stuff, but it depends. Like for example, here I'm using something quite like styled components, so I generate all the styles in the server as well, inject them in the server as well. If you do like this in the proper way, you barely will get like any kind of conflicts. And yeah, I'm even injecting like normalizing here, for example. I can change it right now. I can remove like, for example, the header. If I just save it, well, most probably now, yeah, scaffold is rebuilding my container and deploying it again inside Minikube. It already finished it, by the way. It's restarting the server. Okay, cool. If I just run this right now, most probably I will have no header, without actually having to redeploy anything else other than the layout service. You can also implement something in the layout service to actually fetch these templates, like from a database, from somewhere else. So you can actually just like even make like some kind of interface to drag and drop like the available fragments you have and build templates on the fly. It's kind of cool. It opens some nice possibilities. Does anyone have any questions so far?
Is it similar to if you render, let's say, 2 React apps into 2 different divs on the page and they live simultaneously? Is it
kind of
similar?
Yes, exactly, kind of. Yeah.
How do you communicate data? Like, how do you exchange data between the fragments?
Custom events. We showed implementation.
Everything is custom events, and you just attach some data objects, and
yeah,
each of them understand each other.
So for example, here in the header, you have like the app components. In the coffee shop's filter input, I have like a logic here So what basically it does is that, by the way, using the amazing library Propy by the fella on the back here, it helped me a lot. Thank you very much. So here, basically, what I'm creating is a custom event with like this name. It's coming from the fragment header as a header filter change, and giving the value of it, and just dispatching it in the window and let any fragment actually are interested in this kind of stuff listen to it. Go for it.
Yeah, I imagine that I have sort of router, the payload side, right? But what happens in the client side? That can be a single communication
Well,
next page without the load.
In this case, I'm actually using two types of routers here. So Taylor itself is one of the routers because it will forward the request for the specific template name. You can change that as well to always go to the same template, for example. But for example, I have a dashboard in this application. I can access this dashboard. And it has like subtabs. It has like a tab view. And I need to switch like the URLs between the tab. And if you go to the recommendations tab, for example, you should end up there even though it's your first request. So what I actually do is that like a specific fragment for the dashboard has React router on that, but only that one. Not that much. Only in place actually you need to. But the router is also like in a common dependency, so you can just use it anywhere. Like the only router I have here is the server for Taylor, and it's forwarding to the correct template. And then if that template, for example, loads a router like in the client side, and then it will keep on going on from that one. Any other question? No? Okay, I'll go back to the slides. This was a small presentation of how we can actually build this kind of stuff. Okay.
Is this live?
Live? I'll publish at the end. I was having some problems actually deploying this to Google Cloud today, so I didn't. Sorry, I wanted to, but it's not possible today. But it worked well in Minikube though. So no, this is experimentation of mine, just sharing. Like I know Zalando is using it in production. Zalando is using it in production for 3 years with a lot of different components, but basically this is like the main aggregator of everything. This is what they are using so far. And they're actually getting rid of it because it seems the challenges of actually keeping a consistent UI is way harder than when you have this kind of architecture. So this is what I'm going to talk about right now as well. So there's some things to keep in mind when you actually want to come to this kind of implementation. Complexity will rise a lot. It's not simple. You just have like a lot of front-end applications with different build steps. You have to deal like with require.js, AMD loading, server-side rendering or not, if you're using or not, and this kind of stuff. It will rise a lot of the complexity. It might not be the best approach. There's a lot of different approaches for implementing micro frontends. This is just one of those I wanted to share with you. Having a common library can actually bite you. We learned this from microservices, that having common libraries and trying to redeploy all of them because this is kind of messy. In this context, it worked well, but I'm still kind of not really happy with this kind of solution. You don't even need Kubernetes to run this. You can actually run all this architecture in serverless. Each kind of these components, these fragments can be serverless functions. Next.js, if you use it, like each page got deployed to a Lambda function in Now, for example. They have better approaches in this kind of stuff. Another thing, listen to the ones that are actually trying. Listen to Zalando, listen to Dazon, who's putting this in production, for example, as well. In Travix, we had this a bit. And yeah, there's a lot of struggle when it comes to this. There's no right way, but there's a lot of different types that you can try, even getting everything bundled, single bundle and delivering it, separating this in different services, you name it. Experiment other approach like Frontends. There's the composure I told you about today as well, and there's this awesome micro frontends link. There's like dozens and dozens of different posts and articles about people who have been trying to implement this in a correct way, or at least in a productive way. Maybe just create separated apps for each domain organization. Maybe if you want to decompose your front end, just create a different app for each domain. You don't need to actually have everything in the same app. It might also work. Think for you, like think for what actually helps you in your context and the organization you're working right now. How would feel like as a team to have this distributed way. Don't be sheep. thank you very much. That was basically it. Any questions? Okay, go for it.
Will you or plan to have a repository for this?
I can publish it.
That'd be awesome.
I'll publish it. Yeah. Okay.
How many resources do you need when you want to deploy this application?
Well, this is an 8 gigabytes MacBook running just fine. I don't believe it. You need more than 2 gigabytes of RAM or something like this. Of course, you're having a lot of way more servers and this kind of stuff, way more requests. It will be a bit more intensive than a normal front-end application. So you might want to scale this in a different way. Any other ones?
Share the slides.
I will share the slides. They actually already open. They're in slides.com, so I can share this as well. Okay, that's it. Okay then, thank you very much for listening.